Welcome to Study Loop.
(19.91). We want to find out how much energy is going to be taken out of a 24-volt battery if we charge a 450 nanofarad and 200 nanofarad capacitor, first with those in parallel and then with them in series. And then in both cases, we'd like to know what the total charge is that is transferred from the battery. So the energy that's stored in a capacitor is 1/2 times its capacitance, and in this case we'll be considering equivalent capacitances, times the voltage squared across the capacitor. So in both cases, V is going to be 24 volts. Now with the capacitors in parallel, they just add. So we have 650 nanofarads. And then plugging that into here with 24 volts, we get that the energy that comes from the battery is going to be 1.9 times 10 to the negative 4th joules Now capacitors in series, their reciprocals add to equal the reciprocal of the equivalent capacitance, like resistors in parallel. So for two of them, you get the same formula you can use for two resistors in parallel. And so the equivalent capacitance here is 139 nanofarads. And so then putting that into our formula for energy above, we get 4.0 times 10 to the negative 5th joules. So for the amount of charge, the charge on a capacitor that's been charged up to some voltage is just its capacitance times that voltage. So from part A in parallel, C equivalent is 650 nanofarads. And so that gives us 16 microcoulombs of charge. And from part B, 139 nanofarads is our equivalent capacitance. And that gives us 3.3 microcoulombs of charge.